a test for you, as some people assumed, but it is called the first derivative test.
Some people, as I was not the only one.
Well, you know. All right. So the first derivative test is used to find, to test whether or not the function has a maximum or a minimum. Okay. So if we start by looking at this quadratic equation here, is it obvious to you what it has? It has a minimum, right? And right where that minimum is, what would you say the slope is?
0.
Good. So right where the min is, so I'm going to put min, the slope is equal to 0. Okay. Now, if we examine around this area, the slope right before the slope of 0 is a what type of slope? Negative. So before that, f prime of x is less than 0. After our 0 slope, how would you describe the slope? Positive. Yes, greater than 0. F prime is greater than 0. So what we're going to do is we're going to end up making that into a sign chart. We're going to get our critical points, which of course is when the derivative equals 0. So in this case, that would be at 2. And then we're going to look at the slopes before 2, which we just said are all negative, and the slopes after 2, which we just said are all positive. And that will tell me the function is decreasing and then increasing, which is what we talked about yesterday. And now we're going to add in the next step to it to say, since my slope changed from a negative to a positive, I must have created a min. Okay, so I would say x equals 2 is a min, because f prime of x changed from negative to positive. So x equals 2 is a min, f prime is changing from negative to positive.
I know what it's meaning here, but
Yeah.
I feel like when the theorem or whatever it was we learned yesterday, where it was that all functions of its continuous has a maximum.
The extreme value, yep.
Yeah. My question with that was that even if the graph isn't continuous, all graphs have a range, right? The highest point it goes to and the lowest point it goes
Correct.
to, which are that absolute max and min.
Mhm.
So sometimes it's infinity or negative.
So that can't, infinity isn't an actual number, so that can't be an absolute max or min. It just goes on forever. So it's not defined as having an absolute min or max at that point.
Okay, so then the continuous thing is only over a certain interval?
Correct.
Okay.
Yep. Remember, it's continuous on a closed interval.
But even then, even a non-continuous function within that interval would have a highest point and a lowest point, wouldn't it?
Again, the theorem says you're guaranteed. If it's continuous, you're guaranteed to have it.
Great, isn't it?
I have to move on, Drew, but I will argue with you in study hall. Justification statements. Assume C and D are critical numbers. Okay, there is a min. So again, before you can say you have a min, here's our full definition. You first have to say f prime of x equals 0. So you first have to establish to the grader that the derivative equals 0. Then you can say f prime changed from negative to positive. Likewise, to be a max, I would first have to establish that the slope is equal to 0. And then this time, f prime changes from positive to negative.
What if the derivative doesn't exist? So it's not 0, but it's still a point.
Correct. So it could be 0 or doesn't exist. Yes. Definition of a critical point. So you're first establishing you have a critical point. All right. So number 1. And it's just called the first derivative test. Use the first derivative test to find the x values of any relative extrema. So again, just to hit on this word extrema, that's plural for both maxes and mins. Extrema is plural. Just rewriting my function because I wrote over it. All right, so I want to find my critical points by taking the derivative and setting it equal to 0. So again, what rule am I using? Chain. So 2/3 x squared minus 4 to the negative 1/3. So that's my power, and then times the derivative of the inside is the chain, so times 2x. And I'm going to clean that up for myself. I'm going to say the numerator is going to contain 2 times 2x, or 4x. And I'm going to keep the 3 on the bottom and the cubed root of x squared minus 4 on the bottom. Okay, so when we set the derivative, the critical point again, we set the derivative equal to 0. If I have a fraction, I also have to check the undefined spots too. So when I have that fraction, I'm setting both the numerator and the denominator equal to 0. So when I set the numerator, I just get 4x equals 0, or x equals 0. Okay. And I'm going to set the denominator equal to 0. I think all this junk was intimidating some people over the past few days, just when we were talking things out. Again, it's all just dividing out. I'm dividing out the 3. I'm taking the cube, I'm cubing that. It's all disappearing, and I'm really just setting the inside equal to 0. X squared minus 4 equals 0. And again, I typically factor so I don't lose a sign. So I'm going to go x plus 2x minus 2. So I'm going to get x equals plus and minus 2. Okay, so now we're ready to make our sign chart. We can't answer any of these questions without a sign chart. So I need them in order: -2, 0, and +2. They're always going back into the function we got them from, which was the derivative. So I'm plugging them back into f prime. Okay. And again, I'm going to make sure I'm picking the one that I've set equal to 0. So I'm using this function. So I've got to just watch the top and bottom. Did I screw something up?
No, where did you get that 4x equals 0?
The numerator.
Oh, yeah. Thanks, I just want to ask questions.
That wasn't very kind, Luke.
Hey, I'm just joking with you.
All right. All right. I'm going to plug in. I'm going to start with the positive. I'm going to go with the +3. So on top, I would get a positive, and on the bottom, 3 squared minus 4 is still a positive, so I'm getting a positive over a positive. I'm going to say that's a positive. When I plug in a 1, on the top I'm getting a positive. 1 squared is 1. 1 minus 4 is a negative. You can take the cubed root of a negative. We don't care what the number is. We just need to know if it's positive or negative. The cubed root of a negative is a negative, so this is going to be a negative. When I plug a -1 in, on the top I'm getting a negative. -1 squared is a 1. 1 minus 4 is a negative. And again, the cubed root of a negative is a negative, so this is turning out to be a positive. And then if I plug in a -3, we get a negative on top. -3 squared is 9. 9 minus 4 is a positive, so that's going to get me a negative. Okay, so this is telling me the function is decreasing, increasing, decreasing, increasing. And if you kind of think about connecting those lines, you can visually see what you're getting, right? If I go from decreasing to increasing, what did I just create there? A min. If I go from increasing to decreasing, I created a max, and then decreasing to increasing, I also created a min. Okay, so it asks for extrema, so we just have to make sure we answer the questions. We have relative mins at x equals -2 and x equals +2. And our justification is, again, first f prime equals 0, and then f prime changed from negative to positive. F prime equals 0, then it changed from negative to positive. Then we have a relative max at x equals 0, because f prime equals 0, and then f prime changed from positive to negative. All right, so increasing, decreasing, max, min all need a sign chart to answer any question about them algebraically. Let's take a look at the next page. I'm going to skip that bottom one because I wrote all over it. Assume f is continuous for all real numbers. The sign of its derivatives in the given table are below. Identify any relative extrema. Okay, so think about what's happening. We have a slope that just changed from a positive to a negative. What must have you created if your slope changed from positive to negative? A max, right? It went from positive to negative, therefore we have a max here. If I went from negative to being more negative, did I create anything? No. But then I went from a negative to a positive, which means I created a min. Okay, so identify all relative extrema and justify your answer. So I would say I have a max at x equals -2. And again, that's because f prime changed from positive to negative.
Can you state that it's a critical point? Because it doesn't give us like a
Yeah, this table's showing that they're technically critical points. And then I have a min at x equals 3 because f prime changed from negative to positive. All right, so you're going to see these asked three ways. One is going to be algebraically, like we tackled there. One is going to be tabular, which is this. And then graphical is probably the most common and probably, I think, the easiest of the three. So for each problem, it says the graph of f prime, the derivative is shown. So the first thing I always do is really just label it so I know who I'm talking about. Find all relative maxes and mins of f and justify. Okay, now it's not the max and min of f prime, it's the max and min of f. So if I want a max or a min, I have to first find the critical points of f. I have to know when the derivative is equal to 0. What are my critical points in this picture? -2. Who else? 0 and 2.
And that's another thing I was talking about earlier.
Right, but it's hitting 0, so it's still a critical point. It's just not going to be a max or a min, basically. Okay, so I have to identify all the candidates for the critical points. All right, so f prime equals 0 here, here, and here. Then I need to justify each one as a max or a min. So this is a graph of f prime. What do I know before this critical point about f prime? It is a what type of number? Positive, and after this number it is a negative. So I can say x equals, what is that, -2 is a relative max because f prime changed from positive to negative. What can I say about 0? Therefore, it's neither a min or max. X equals 0 is neither a max or min.
Do we have to write that? It doesn't say to identify.
It doesn't. I'm just talking them all out. F prime doesn't change signs. Pretty sure it does on the spiral this week a few times. So might as well practice now. Doesn't change signs. Then lastly, x equals 2. Before 2, f prime is a negative. After 2, f prime is a positive. So if I went from a negative to positive slope, I created a min. So x equals 2 is a min, a relative min. F prime changed from negative to positive. All right, you try 3. There's not a ton of room to write here, but just identify your critical points and if they are maxes or mins. This is a graph of f prime, and yeah, they're both f primes. So this is f prime. Anna, give me a critical point, whether it's a max, a min, or a neither. Negative 2.5. I like that critical point, and what are we saying there? Max. Excellent. F prime changed from positive to negative. Emily, give me another critical point and tell me what you're thinking. Yes. Relative min, F prime changed from a negative to positive. Leo, give me another critical point. Three is a critical point, and max, min, or neither? Neither. F prime doesn't change signs. And Mallory, last critical point? You got it. What are you going with? Neither as well. F prime doesn't change signs. Okay. All right, let's see. Okay, so number 4 down here, it says for each problem, the derivative of the function is given. So they're trying to be helpful, right? They did the calculus. You just have to find the maxes or mins. So they already took the derivative for you. All you have to do is set it equal to 0 and tee it up. So I've got x plus 4 equals 0 and e to the x equals 0. One easy solution is just x equals negative 4. Yesterday we kind of reviewed 2 ways to think about this. We can think of the graph of e to the x. Does it ever hit 0? No, so there's no solutions. Or if you try to take the ln of both sides, the ln of 0 doesn't exist, so again, no solutions here. So my only critical point is at negative 4. And these are going back into, they called this g prime, so g prime of x. Yes?
What does it look like when it doesn't change signs, but it's still good?
So something like this, that it bounces off the function.
Yeah, like what would that look like in the graph?
Oh, like the original function.
Yeah.
If it doesn't change signs, so something maybe like this, where it kind of like saddles. So it still has a slope of 0, but it's still positive slope, so the signs aren't changing. So we're going to plug somebody in on each side. So who's bigger? Who's an easy number bigger than negative 4? 0. Anytime you can use 0, use 0. So 0 plus 4 is a positive, and e to the 0 is a 1. That's a positive, so we're getting a positive, so we're increasing. And then if I plug in a negative 5 plus 4 is a negative. Now again, be careful with e to the negative 5. That really just turns your answer into a what? A fraction, right? There's nothing negative there. So that's a negative times 1 over e to the 5th. So I have a negative times a positive, which is a negative.
I just always, whenever there's an e, I just write it as positive because e is always positive.
You could think of that too. E is always positive. But in this case, I'm just multiplying by that negative. So I can say a lot of things here. I can say x equals negative 4 is a relative what? Min. And again, if you just draw the arrows, it should look obvious. G prime of x changes from negative to positive. And then just to pony off yesterday, we can talk about the increasing and decreasing. We know this function is decreasing from negative infinity till negative 4. Remember, increasing, decreasing are always going to get a bracket. And that's because f prime of x is, g prime of x is less than 0. And then increasing from negative 4 until infinity, because g prime of x is greater than 0. So just kind of tying the 2 days together. All right, I'm going to assume we can do this one just because it's already simple. Let's grab the next one. Bless you. All right, this says use your calculator. So let's grab our calculator and just make sure we can answer a calculator question. Again, half the exam is calculator active, half is not. So it says use your calculator to help find all x values of relative mins or maxes of f. No justification necessary. So again, I want to be thinking, I want to set the derivative equal to 0. This is super nice because it already is the derivative. So all I have to do is graph this thing. 6 cos of x squared plus 2. And after we type it in, we're always going to start on zoom 6. So I want to say to myself, this is a graph of f prime already. So just keep that in mind. We are staring at f prime. So my critical point is where this picture hits 0. So these are my critical points, where it hits 0. And I want all maxes and min. Are each one of these going to be a max or a min? Yes, they're all changing signs. So let's go get the first one. Does anyone remember what the feature is called you have to use? 0, yep. So second trace 0. Okay, so I'm going to go over to that first one. You just start by getting close to it. And then you have to play like the left-right game. You have to go on the left side of it. So I have to go on the left side of it, hit enter. A vertical line will appear. Then I have to go to the right side of it, hit enter, a vertical line will appear, and then you take your guess. So make sure you try it and can get the zeros. I'm getting negative 1.922. Remember, 3 decimal places. And I'm just going to note that that's a relative min. And then you'll get the next one, just play the same game, second trace 0. Get close to that next point, and then play the left-right game. Go on the left side of it. Go on the right side of it. I'm getting negative 1.250. This one would be a relative max, because f prime is changing from a positive to a negative. And then I'll get that last one. Go to the left and the right. I'm getting a 1.018. And that's a min. F prime is changing from a negative to a positive. How's everyone doing with those? Tree, slow down. Don't take the fun away for everyone. How you doing?
Good.
Good?
Yeah.
Are you sure? You want to zoom in?
Yeah, I got it.
All right. Dree, are you sure? I'm gonna graph the next one, Dree.
90%.
That's it? That's not enough. All right. You don't think this changes signs?
I tried. There, no sign change.
Eventually? Will those ever go negative? Nope, must be, oh, there's an asymptote there. Right. I don't know, Dree. I think it does go negative. I think I gotta change my window. Let's see, whoops. Left bound. Right bound. I think I got a 0. I think it happens on the 10 by 10 window.
Yeah, that x equals 7.39.
A little bit. Is it a max or a min? Max, because f prime's changing from a positive to a negative. Okay, so it does look like it does change. It's very hard to see visually. That's why you want to double check it mathematically here. But there is a sign change at 7.389. Do we get the idea with the graphing part? I don't need to do another one. Let's do a couple of these. Let's do some fun trig ones. Let's find a trig one. Everyone loves trig. Let's do some fun. Let's just jump down to 13. Let's tackle some trig. All right. What is the maximum value of this function on the open interval negative pi to pi? All right. So the moment I see min, max, increasing, decreasing, I'm using what we call the first derivative test. You have to set the derivative equal to 0 and make a sign chart. So g prime of x equals, I'm getting is negative 2 sine x. Oh, this isn't even an ugly one. Equals 0. This one's way too nice compared to the homework. Divide out the negative 2, so I just get sine equals 0. Okay, so we're picturing our sine curve. We're picturing when it hits 0, how many answers do we have? 3 at 0, at pi and 2 pi. Now, oh, this was way nicer than last night's homework. They also killed the interval. They said it only goes from negative pi to pi, so I'm going to reject the 2 pi. I don't have to go that far, but I'm also going to add in a negative pi because it's symmetric. So I'm going to make my sign chart. I'm going to stop it at negative pi and pi. So really, my only critical point to test is 0. All right, and we're plugging these back into G prime. So again, when I have trig, I try to pick somebody on the curve that I can visually see. That makes my life a lot easier. So if this is pi, a smart number to pick between 0 and pi would be pi over 2. And again, I'm going to plug it into this one here. So when I plug pi over 2 in, I get negative 2 times the sine of pi over 2. Sine of pi over 2 is 1. So I get negative 2 times 1, which is a negative. Then in this case, I'd plug in negative pi over 2. So if I plug in negative pi over 2, if I just continued the graph, negative pi over 2 is equivalent to negative 1. So that's going to make that a positive. Okay, so we have a relative max at x equals 0. F prime changed from positive to negative. Now this question actually was worded differently. It actually said, what is the maximum value? So this is where the max occurs, but now it wants the value of the max. Okay, so now I have to go actually figure out how tall the graph is at 0. So all I have to do is find the y value at 0. So I'm just going to plug 0 back into that original function. 2 times the cosine of 0. Cosine of 0 is just 1. So I would say the maximum value is 2. Does that make sense? A relative max. Is that what you're thinking?
The A.
Amplitude.
Yeah.
Yes, the amplitude if you were to graph it. Very good. Okay, so our maximum value is 2. So just watch the wording if it says where does the max occur versus what is the maximum value. All right, that didn't turn out to be as ugly as I was hoping. Go try number 10. Let's try something with ease. Set that derivative equal to 0. Right, take the derivative and set it equal to 0. Bless you. Alright, so we'll go in first. Up this side. How does x e to the 5x times 5 plus e to the x sound? Okay. The moment I do product rule, what should my next step be? GCF, yes, factor out a GCF. So I'm going to pull out e to the 5x, and I'm left with 5x plus 1. Okay. I'm going to set that equal to 0. So I'm setting e to the 5x equal to 0, and 5x plus 1 equals 0. What do we know about our e function in 0? Never hit 0, so that side doesn't exist. And here we just get x equals negative 1/5. So only one critical point to check. These are going back into g prime of x. So negative 1/5. Again, I'm going to test a 0 on this side. E to the 0 is always positive. 5 times 0 plus 1 is a positive. I'm going to plug in a negative 1. E to anything, again, is always positive. Negative 5 plus 1 is a negative. So that's going to be a negative. And this just said, Leo.
So I would be truthful on this.
Yes, go for it.
When you add the 0 in, doesn't it just kill everything? And then there's no sign,
So it would only equal 0 if you use the critical point. Otherwise, nothing else should equal 0. So when I plug a negative 1 in, I've got 5 times negative 1 is negative 5, plus 1 is negative 4. And then e to anything is always positive, so I'm getting a positive times a negative. If you plugged a 5 in here? The only thing that would make this equal to 0 is negative 1/5. So if that's happening, then we made a mistake someplace with like the critical point, because that should never happen. So we've got a relative min at x equals negative 1/5. F prime changed from negative to positive. Sorry, totally off the paper. F prime changed from negative to positive. All right, grab the 2 cards. Okay. And let's put a relative max on one card. So to be a relative max, don't forget first the derivative must equal 0. Or doesn't exist. It must be a critical point. Maybe I'll just put CP for critical point. And F prime changes from positive to negative. F prime, now, and I'm just going to make one more note, because after we get halfway through the year, you're going to forget these things. You also need to make a sign chart. Like, you can't do this without a sign chart. And then I'm going to go relative min. So likewise, we need the critical point, so setting the derivative equal to 0, or doesn't exist, and f prime changes from negative to positive. And again, you can't answer this without a sign chart. All right, stick those in your ring. All right, grab your book real quick. I'm going to tackle this real quickly. Page 191. All right, example 4, page 191. We are staring at a graph of h prime, so keep in mind you're already staring at the derivative. On what intervals is h increasing? So you are staring at the derivative. We want to know when h is increasing. So let's start with the justification. How do I know h is increasing? Who am I looking at? Yes, h prime is greater than 0. So I always start with my justification first, and then finding it's usually easy. H prime has to be greater than 0, and you're looking at h prime. Joey, give me one interval where h prime is greater than 0. Negative infinity to 0 is perfect. From here on, and again, if it bounces, that's okay. We're taking that in our interval. Negative infinity to 0 is perfect. Luke, give me another one.
Hold on. Counting down. Oops, sorry, what was the year? I wasn't paying attention, I'll be honest. I was trying to copy down and find a page.
I love you, Luke. H is increasing when h prime is greater than 0. Where else is h prime greater than 0?
What did they say? 0 to 1. Or 1 to infinity.
Yes, 1 to infinity. Way to recover. Love it. All right, letter B. When does h have a, does h have a local min-max or neither at negative 2? At negative 2. Neither. Why neither? All right, just don't say it. H prime doesn't change signs. Well, I'm just making sure we're all on the same page about the word it. All right, we're looking for a relative min. Relative min. Where do we have a relative min? What are only candidates to be a relative min? Negative 2, 0, and 1. Because that is where h prime has to equal 0. Which one of those is a min? X equals 1. H prime changes from negative to positive. Got the idea of increasing, decreasing? Derivative has to equal 0, and then we're looking for either negative to positive or positive to negative.
Yeah, like what would be the reason?
Yes, so I would first say h prime equals 0, and then h prime changes from negative to positive. Yes. I did, yes, thank you. All right, so I think there's 7 questions. I think they mirror pretty good.